We're still studying volumes of revolution. We're gonna change our axis of revolution today. It's not gonna be the x-axis, okay? But you have to remember, it's top minus bottom. It's a very big theme in this chapter. Okay? So I'm going to show you a couple examples. Hopefully, okay, this is called the wedding band. You'll probably see why. Pretty much. Yeah, mathematicians, you know, we're artists. So we're going to revolve or rotate the region between y equals x squared plus 2 and y equals 4 minus x squared around y equals -3 this time. Look, yesterday we were doing x-axis revolution. Today it's y equals -3 in this case. It's y equals -3 is a line.
So that's just like where it's being rotated.
Yeah, so if I draw this up, y equals x squared plus 2, black. There's 4 minus x squared. You can see the shape here, right? So this is our region. And then we're going to revolve it around that line. We've been doing the x-axis, which is 0. But now we're going to take this and rotate it around that one. So, remember always, so a book writes that equation. So you have to figure out where, and you can also write it top minus bottom. So which one's the top? The red, right? Well, what is the radius of that circle? If we rotate it around in a circle, right? And this is our center. What's the radius of that circle? It's the top minus the bottom. Okay. In this case, it's 6, 7, but in general, it's the function 4 minus x squared minus -3. Top minus bottom, right? Top minus bottom. Huh?
Why don't you use,
You're going to, it's the inner. So remember, top minus bottom. Top minus bottom. Then inside each one, it's top minus bottom too. So we have the outside radius of the circle. It's top minus bottom, and the next one is right here. So you have x squared plus 2 minus -3 as well. top minus bottom. Okay, the beam hits in top minus bottom here and inside those parentheses when you're not revolving around the x-axis. So picture it this way. We're revolving this around and we're getting a circle, right? And here we have a circle. So basically what we'll end up with is it's a wedding ring, because it's got, you know, that shape, right? You have an outside radius, right? That radius is top minus bottom. And the inside radius top minus bottom.
Oh.
Of the circle. Okay, so see this big circle out here? You need the radius of that. So it's top minus bottom. And the radius of the inside is top minus bottom. Okay?
Is there a difference between the wedding band and the washer? Or is it different?
Well, a washer would be a cylinder with a hole cut through it.
Okay.
Right, a wedding band, see how this is shaped? You know, a wedding band is rounded, so it doesn't touch you, right? So that's why we have, this would be more of a male wedding band, I think. We don't need to get a finer points before we do. So here's the setup. What are these points? The limits, like the integral limits. Okay, we need these two numbers, right? Yeah. 2x squared equals 2. Negative 1 to 1. I don't know why I wrote positive there, but whatever. I was thinking positive, so let's speed out. So let's simplify here. 4 minus negative 3 is 7. And then 2 minus negative 3. What's your next step?
You take the.
No. We need to FOIL.
Oh.
Yeah, FOIL them.
No.
These are not integrals that we can calculate because there's nothing. See the x squared inside the parentheses like I was talking about earlier. There's nothing out here to use substitute. So we have to FOIL these out, combine, and it makes a nice polynomial.
Real nice.
Yeah, I said it. I said it. Nice. Pretty. Beautiful. It's jewelry day.
Jerry.
Don't make me mad. You don't know hostility.
You never been done with
It looks like the most fun stuff I've ever done in my life.
Talking trash about me.
Oh, I said not you.
Mr. Arthur just wants to start. Yeah, he's just looking for it.
Preferably with the smallest person in the room.
Yeah.
That's brutal.
I got it. Better than Steven.
Yeah, I bet you do. Bring it.
I
Snap you out.
Okay, what's our final here? 49 minus 25.
Yeah.
Yeah. Okay, and then negative 14x squared and 10x minus 10x squared. Oh. And what are the x squared fourths give us?
Zero.
Yay, how about that? And now you have an integral Now you're ready to do your antiderivative and evaluate.
Your eyes is so.
I think it is. You try to make these as simple as possible, just take them a step at a time. Set it up. Make it a nice integral, calculate the answer. All right, next. Think you have a question.
So on this one, you told us to boil the things, right?
Right here.
Yeah. But over there, we didn't.
Where?
So there was in the.
Here?
Yeah.
We don't need to. Okay, see how this is x plus 1? What's the derivative of x plus 1?
That's what Chester told me, so.
The derivative is 1. Right, so the inside here is friendly for intervals. This derivative is negative 2x. Not friendly.
Oh.
Right. So we have a chain rule problem here, so we need to get rid of that. One more. Let's look at, example 4. Let's revolve, find the volume. Obtained by rotating graphs of nine minus x squared and y equals 12. So here's our line we're revolving around. Like this 15. Y equals 12 forms our region as well as 9 minus x squared. This nature. And 0, 3. Right? So we're going to take this region and revolve it around that one. Again,
How do you know this? Oh, three.
yeah, there's a lot of information in here. If you need to, reading strategies, you know how to annotate. You can just say, oh, it's around this. Here are my integral limits. You can say, okay, I'm just going to note that. Puts it in my brain for annotating, right? Okay, these are my functions, so maybe top, bottom. You can write anything you want. Okay, I suggest it. And every time you do one of these, because you got to memorize these formulas, I suggest writing the entire formula out. So every time, write it on every problem, because you want these to be automatic. Like, your mind's gonna melt if you have to think about putting these on paper. You just need to come out. You need to, like, we're 2 months from the AP exam, it's the time where you need to start having these memorized. That's what we do the flip cards. So. 0 to 3, right? Okay, what's my outer? My largest radius is right here, correct? This is the smaller. So this is my outer. Top minus bottom. So 15 minus 9 minus x squared. It's my outer radius of the circle. The bigger of the two. Now my inner is what? 15 minus 12. Yeah, that one's easy, right? And now you have your setup. So you go, every one of these problems go into it the same way. Formula, top minus bottom. Okay. So what do we got here? 15 minus 9 is 6. See, you just caught my error because it was right there obvious. You try to do that, and like if I had put 3 steps in a row here, it would have just kind of probably disappeared into a mess, right? But it was easy to see it. All right, FOIL that out, you get 36. FOIL x, and then 36 minus 9 is 7. And then you have another integral, you can calculate the value of that, right? We get plenty of practice calculating integrals, like I told you yesterday. Do you want me to finish that, or are you good? Yes? So actually. Okay. So you remember yesterday we were revolving around the x-axis. None of this subtraction business in here. It's just the function. Today we have a different revolution, line of revolution, so you have to have the top minus bottom. We give the rest of the hour to work. A good time to ask questions. Write down the formula every time. And just go step by step. Have your work? Oh, I didn't give it to you yesterday. I gave you yesterday's yesterday. Not today's yesterday.
No, Alex, it's
Are you
home.
confused,
Not
Alex?
tears of sorrow.
Yes, it is.
That's when you get home.
And you have to do the two.
I've never done that. My 4 years of high school.
Okay, this would be today. Stuff that I take. Tomorrow, we'll do y-axis revolutions. And spiraling. This would be what I showed you today. But this is not due tomorrow. This is all due, I'm gonna decide here.
The examples,
This will be matched with the exam possession.
not 6.3, but that's
This tomorrow. 6:23. 3 days now. Another reason we scored over today. And then AP 5, 5, and 6. So. You're gonna be gone Friday. Oh, you Tuesday. So Tuesday. And you're gonna be gone tomorrow too, right? All of you, so watch the video. If you don't have the AP problems on Friday, get them. You Tuesday.
Don't worry, I'll be here.
I was hoping of all people that you would be gone.